Alright, so I've completed the battery soldering on both sides, both of these sets of straps. As you can see, these have all come through pretty well. I haven't had a lot of issues with them popping off of any of the cells. So the next thing I'm going to proceed to do is I'm going to install the power output leads, which are going to be made out of 8-gauge silicone wire, and I'm also going to be installing the balance leads, which are going to be made of 22-gauge wire. So I'll start off with the power leads. You can see I've taped off the ends of them so that they don't short out against anything while I'm working. And I've also pre-tinned the ends of both of these cables, both of these wires. The reason I've done that is the strands of silicone wire are actually thinner than a human hair, and as such, if you don't keep them contained, they go absolutely everywhere. They can short out your battery and start fires and cause all kinds of other problems. So you want to keep those well contained, and when you finish your soldering, you want to double check that none of them have broken off and gotten away. So I'm going to be connecting the red positive side to this set of parallel straps here. So I'm going to get this into position to where I can solder on it as easily as possible. And what I'm basically going to do is I'm going to probably take it along this center line here. See if I have enough. I might need to cut a little bit more insulation off. See if I can get that insulation off there, hopefully without causing too many stragglers. The nice thing about silicone insulation is it's pretty soft, so you can just break it off with your fingers usually once it's been cut. So I do see one strand there. That should be okay, shouldn't cause too much trouble. And we're going to see if we can then line this up and get that installed. So I'll take the end that I've already tinned, and this is probably going to take quite a bit of heat, so I'm going to go ahead and turn the iron all the way up to the top, really get it hot. In fact, let's just take it all the way to 500. That's going to just dump tons of heat into here. And the first thing I want to do is basically get the end of it hot enough that the whole thing is going to melt. I want to get this thing just basically tack welded on to the battery. Let's see if I can just hold that in place like this. And once it's tack welded on, I'll be able to go back later and reinforce it. So here we go. Now that's kind of temporarily installed. And now I'm basically just going to go point to point across each one. Now this time I'm going to add some extra flux just to really help get the solder to flow into the cable, and I'll do that each time I solder to it. So we're going to absolutely bathe this thing in solder, so I'll get plenty of it off the roll. And let's see what we can do here. Get plenty of it just soaked into the fibers. Now we want to still be careful not to overheat the cells. So we'll try to avoid excessive dwell time. But at the same time, we want to get it hot enough that we can flow that solder in. Try the other side now. Setting the iron to 500 Celsius basically makes it just power through almost anything, but it also makes it a bit hazardous because that cell under there is going to get pretty toasty if we don't watch the temp. So that's a pretty good bond. You can see it's flowed onto the copper strap on both sides there, so that's probably not going anywhere. So now we're going to go back to that first one and reinforce it a little bit, since it was basically just there as a sort of tack weld. And you can see that a straggler has come off, so we'll be sure and clip that for safety, because that could get into the tops of the batteries and potentially short them out, which we do not want to happen. Even a small fiber like that could potentially cause enough heat to build up that it could result in a chain reaction. So get some more solder into the wire. Oh yeah, when you get the iron up to this high of a temperature, things happen pretty easily. Solder flows nicely. Now you don't want to keep it at this high of a temperature because eventually it will tend to ruin the tips. They are quite susceptible to oxidation when you're above about 400 Celsius. Additionally, if you're ever soldering on like integrated circuits, you don't really want to go above around 300 to 350 Celsius because you can then damage the silicon inside those integrated circuits. So try and hold that in place if I can. Pre-tin it. Get it nice and hot. This is kind of not wanting to hold itself in place very well, so I might come back with some other tools. Maybe that'll be good for a start. Maybe I'll do this next one down here and then come back to that one. So we're going to connect this one. This one is also trying to not make good contact, so I'm probably going to have to change the tool that I'm using to hold this wire in place. Right now it's just kind of hanging off the edge of the battery. But we'll see what can be done. This might actually work fine if we can get a good bond to the copper. Yeah, so that's bonded now, so we'll come back to this other one up here, maybe reflux it a little bit and see if we can get that one to stick. And then if that one sticks, we will return to this front one and finish it. Because the copper braids are going to absorb most of the current, basically we just need to get fairly even distribution of current amongst the cells. What you don't want is for, let's say you're cranking an engine with this battery, you don't want like these first few cells to do all the work and then have all the other cells subsequently have to recharge them through the strap. If you do that, that severely shortens the lifespan of the pack. The ideal case is to get all 20 cells to pretty much evenly discharge, and the trick to making that happen is basically getting your cable to be as evenly distributed in terms of contact area as you can. So that second one there looks pretty good. I'm going to go back and hit this end one again because it's kind of sticking out a little bit. And it's almost on there. Not quite. It's just a little too far away. I don't want to cook the cell underneath it. But let's see if we can just soak some heat through if we press the iron down from the top like this. That's pretty good. Yeah, maybe I'll add a little bit more in this corner and then I think I'll call that good. Yep, that looks perfect. Now there's a couple more stragglers in there, so I'm just going to point those out with the tweezers here. And I'm just going to grab my wire cutters from the side over here and cut these stragglers off so they don't cause problems. So that's the positive side cable connected. That's our 8-gauge major power connection. That's going to carry a substantial amount of current. Ideally, this battery pack will be able to deliver a maximum current of 400 amps for brief periods of time. The 8-gauge silicone wire is rated for a continuous duty of about 150 amps, and for short periods of time, such as cranking a car engine, it should be totally suitable for pulling around 400 to maybe 500 amps. The cells are rated to 20 amps each, so between this entire pack of 20, I should be able to pull 400 amps pretty much continuously from the cell's perspective. And of course the limiting factor will be the cable, which is a good place to be because it means the cable will burn up long before the cells physically fail, most likely, provided that there isn't an excessive amount of heat soak from these connections in. But since the copper straps are so thick, I think it's not going to be a problem for these cables to be connected this way because it's going to distribute the current pretty well regardless. So I'm going to move on now and I'm going to do the negative cable off camera and I'll show you the results for that in a moment. Alright, so there's my negative cable installed, as you can see. So now I've got the positive and negative cables connected to the battery. And the next thing I'm going to do is probably put the balance leads on. So I've got these balance wires here. And the way I'm going to configure those is the ones that go on the end I'm going to do first. And I'll connect them to part of the straps on the ends of the battery. So I'll turn this back over. And I'll start out with the negative one. And for balancing, it's a little less critical where you place these because they're not going to be subjected to a lot of load. But in general, it's a good idea to keep them kind of centralized so that you're getting the most accurate sort of readout of the battery voltage as possible. So I'm just going to basically tack mine onto this big negative cable in the middle so that I get a decent sort of reading of what voltage is on the majority of those cells. So I'll turn the iron a little bit up, not all the way up to the top. See if I can just get a little bit of melting going on there. And let's just see if we can get this to bond. And add a little bit more heat, and a little bit more solder. And that should provide a decent enough bond for the balance lead. So that's our negative balance lead connected. And I'll be careful not to let the ends of these touch anything because I didn't really put any tape on them, so I don't want those arcing and sparking. Now I'm going to wait to do the center ones for a reason that will become apparent in a minute, because those ones are going to... This is not the final form of how the battery is going to be laid out. You'll get to see in a minute how I'm actually going to basically fold it up so that it's the cells are sitting horizontally so I can put straps around them. So, we'll do the positive side next. Pretty much same story. I'm going to get some fresh solder in here. And while that's still hot, I'll take one of these red ones and basically just get it incorporated there. And that should do the job for that balance lead. So we've got our two end balance leads, which are going to go off to the BMS later on. Let me get some more supplies and we will fold this battery up and then install the central balance leads. So I've cut out a couple of sections of shop towel here, and I'm just going to be using this as mechanical padding when I fold these battery sections up along around this axis in order to make sure they don't grind up against each other. Now this is not for electrical contact or electrical insulation or anything like that. It's just basically a protection inside the battery to make sure that they don't basically scrape up too much and cause too many problems. I may resize the way I've cut those, but we'll see how this works for now as is. So I'll basically get the same thing set up on the other side as well. Basically I want a couple of layers of just general protection from mechanical abrasion. I don't want these things to rub against each other and then break off their connections. This whole thing is eventually going to get wrapped in electrical tape though, so it's not super crucial what size these pads are. In fact, I think this will actually be okay. So the next thing I'm going to do is I'm going to basically use these little U-shaped runs of copper to attach my central balance leads. So I'll get started with that. Pre-tin this. And I guess this will be interesting to see if the microfiber cloth is thermally stable or not. So I'm being careful not to short the ends of those balance wires. That should be good. Just bend that tip down there. And for the last one, we'll flip this over one more time. Oh, I seem to have melted the tape a little bit with the iron. Gotta be careful of that. Make sure everything's exposed here. And I'll do the same thing again where I pre-flux the line there. Flow in some fresh solder. Grab my last balance lead. And get it nicely soldered in, just like that. So we've attached our balance leads to the pack. Now we can move on to basically packaging this thing up, taping it all together, and then connecting the balance leads to the BMS. We'll do that next. So the battery pack has basically now been mummified in electrical tape. I've covered it over so that all of the different parts are no longer exposed, and the tape is going to provide some general structural rigidity to basically hold the pack firmly against whatever surface it's going to be mounted to. Now the cells are oriented in this direction, which means that I can run zip ties over them and still get good structural integrity without crushing any electrical contacts on the end. Eventually the whole pack's basically going to be zip tie mounted to a small piece of plywood, which will then be set into our final container box later on. So this brings us to the point at which we need to wire up the battery management system, which is this board here. Now this is only going to be used for charging, not for discharging, and the purpose of it is going to be to balance the cells during charging, and also to make sure that when the cells are charged, that if there's a slight overvoltage from the control circuit, which is this device here, that it'll terminate charging before reaching an unsafe level. It's basically an extra redundancy to protect against overcharge of the battery. So I guess we can begin wiring this. Now for this I'm planning on mounting it to the side of the battery around here. That way when a zip tie is wired or is pulled across it, it's not directly compressing this BMS. So to do that I'm basically going to line up the conductors and I'll cut them all to length. This is going to be our B-, which is our first one in line. Cut this here. And I'll get the wire strippers out and strip the wire and attach it. Now we want to only attach these one at a time just to make sure we have minimal risk of accidentally causing a short, because the full power of the battery is still connected to each of these balance lines. So I've pre-tinned these. I might pre-tin them again since I let the solder dry a bit. There's not a lot of flux in here. So I'll just pre-tin all the B-, B1, B2, and so on. And you always want to use a BMS like this anytime you're building any kind of a lithium battery pack, just as a method to make sure that the cells are not being overcharged or damaged. Now if you're using an external balance charger like a LiPro IMAX charger, then you don't necessarily need one of these BMSs. It's definitely not a bad idea to have, though, for general balancing purposes. So that's our B-. Now if you look on the back of this, it tells you the 3.7 volt, which is the first cell, can be connected to B1, B2 is connected to 7.4, and B+ is connected to 11.1. This basically is a little chart to tell you which cell you should be connecting to which input. So this is our 3.7 volt. We'll cut approximately the same amount of wire needed for that. This will get us our 3.7 volt connection, like so. And we can wire that to B1, being very careful not to accidentally touch any other conductors or contact points on there. In fact, I am actually going to make this a little bit shorter. Oops, now I've made a mess. As I was saying, I was going to make that a little bit shorter, just so that it's minimally likely to touch any of these other components that might be susceptible to short-circuiting. So I'm going to just melt that pad. And now that the solder is hardened, as you can see, I've made a joint between that wire and the B1 pad there. So next I'll connect B2, which is this one here. And I'll do a similar procedure. This one's already about the right length, so I won't cut any of it off. Connect that to the B2 pin. Being careful, of course, not to short to anything else on the board because it is energized now. And last but not least, I'll be connecting the B+, which I think I'll also keep at its original length, which I'll connect to the B+ pin. So that's all the battery connections made to the BMS here, as you can see. The next stage is going to be connecting the P+ and P- for supply power, which I will do once I cut those wires. So I've soldered the P+ and P- wires to the BMS. These are going to be the wires through which the charge current is run. And basically now I'm just going to find a good place for this BMS on the battery, and I'm going to secure it in place with some more electrical tape. It doesn't need to be super well ventilated because it's not going to be dissipating any heat during normal operation. And unlike the charging controller, it's actually going to be attached to the battery rather than connected externally. So I'm basically going to put it on the side of the battery here, so I'll just kind of cover it over like this and just loop a few more wraps around it, and eventually also around those other conductors. And this is just providing some electrical insulation so that if there's any loose wires or anything else in the chassis of the box, that they are less likely to come in contact with this and cause damage or potentially a catastrophic failure. So let's just wrap that. I'm almost out of tape. And that should be adequate. See about cleaning up some of these other wires as well. But you get the gist of it. Now we've got our BMS attached to our battery pack so that we don't have to worry about having unprotected connections out in the open in the chassis of the pack. So this is basically the first edition of this battery. This is going to be put inside of a metal container, which you've already seen at the beginning of the video. And it's hopefully going to be moving on to the next stage at this point. And the next stage, of course, will be wiring the charge control, which is a constant current, constant voltage charger, as well as basically mounting it up into the actual container and case. So next I'm going to go drill the holes in the case and prepare everything, and we can then proceed to actually mount this thing up and wire up the remainder of the connections.